Okay, so let's see how some ways we can use the hash functions, and they're primarily used for integrity. So for example, let's say that you go to a website, Alice goes to a website, and she wants to download, Linux source code, right? So you basically have a link to the code, source code, and then you notice that there's a hash often that's showing up there. Why? Well, because then when Alice clicks on the code to download it, there's going to be a download site, okay, from which she's actually going to get the source code. So she's going to be redirected to that, and she's actually going to download the source code. And then she's supposed to have the hash from here. Okay, so let's say that this is hash H. So what Alice is supposed to do is she's supposed to hash the content of the source code, and she's supposed to check whether it equals the hash H. And why? Well, because we worry about an attacker here. Okay, so we worry about an attacker, actually more than if, because if eavesdrops malice. Because malice could actually try to change the source code and insert an exploit into the source code that Alice is downloading. Okay, so she could have compromised the whole channel here, but as long as the hash comes from a trusted source and it was not compromised, then Alice will detect that there was a compromise. So which of the two properties of the hash function is this relying on? One way or collision resistance? Collision, exactly. This relies on collision resistance because if malice was producing a source code prime or star that has issues, then its hash will be different from the hash of the actual source code by collision resistance. If they were to be the same hash, then you found a collision in the hash function, and that's assumed to not be possible at the moment. Okay? So you're really assuming that this part is trusted. So assume H is, trusted, it's correct. So if that's the case, then the whole download site could have been compromised. Can you think of any other uses of hash functions? Perhaps you have encountered them, ideas, or any thoughts on what else you could use them for? Password hashing, yes, password hashing. And all right, so we're going to talk about password hashing a bit later in the class. The server stores the hash of the password as opposed to the actual password. And what property do you want from the hash function in that case? Yeah, exactly. You want one way because you don't want someone to be able to, from the hash, reconstruct the password. We'll see later how people go about enumerating the passwords and then hashing them and seeing that the hash matches. And that's not so much, when they succeed to find the password that matches the hash, that's not so much a violation of one way, because one way holds when you really chose, your X at randomly, so when your password was randomly, but it's a problem with the fact that people don't choose passwords that are actually random. So then it's easier to enumerate them, especially if they're simple things like 1, 2, 3, 4, or job or work.